This is just going to be a short module on business models that are, I want to be very specific to what we've seen in modeling and simulation. So not business models in general, but things that you're likely to run into during your career as a modeling and simulation professional. Um, the main thing to keep in mind here is that you really want to understand the process of how modeling and simulation products actually find their way into the marketplace. And the more you understand the different ways, different combinations of how things can be put together, the more you can understand what the value chain is of who is actually adding value and what you should be paying for. So the business models, they got to provide value at each link in the value chain. And I'm going to start by sort of comparing just loosely to the gaming industry. We're not the gaming industry, although there is certainly an entire serious games component to modeling and simulation that is very much like the gaming industry. But even so, it's serious games, not entertainment games. And so the business model, even though the development may be similar, the actual business model and how they make money will be different. So a simple flow model, very simplified in terms of how modeling and simulation products find their way to you. If you look at this, you'll see that there has to be visual content. So we have to create terrains, vehicles, devices, whatever it is you're doing a medical simulation. It could be virtual patients, human models, and anything that you're going to be seeing, hearing, touching has to be developed in some way. That's, I'm calling that visual content, but it's just content in general. Um, and there's models that go along with that, not just the visual component of the model, which would be basically triangles, but also the procedural model, right? How does it behave? How does it interact with other things? Um, and there's tools that feed into that. So we don't build any of that content purely by hand with a simple editor. We have specialized tools depending on what the type of content is that you're actually developing. Then these go together into some type of a runtime environment. So if this is a serious game, this is going to be a game engine. But we have simulation engines that are very similar to game engines, but not exactly the same. They have some specialized features for us. There are, of course, tools that feed into those runtime environments. So um, in the same way that if you would be looking at, let's say, Epic Unreal has runtime tools that help you develop the runtime environment for your game. Do the exact same thing in modeling and simulation. Then, of course, you got to have your hardware. So that's not just your computing hardware, your GPU, but also your interaction devices. If they're going to have haptic devices, head-mounted display, a tablet display, all that stuff all has to be accounted for, and that's what actually ends up into your application. So if you just this is a very crude picture, but I wanted to at least this is going to be important as we go through the different business models to look at which element of this process that particular client or vendor is actually going to be contributing to. Um, so the different components, there's a lot of different roles, responsibilities associated for each of the tools for each of these, and the business models are going to be linked to these. All right, so let's just walk through this. I've just got a couple of tables here, so you can kind of see. Starting at the top, what we call a turnkey system. This is sort of a everything you want in a box. So this would be the sort of thing that you would go to a show expo, you would see a live demo, and you'd say, give me one of those, right? You buy the entire thing. It is a turnkey solution. There's a number of different vendors for these sorts of things that are specific to different industries. So the medical industry is going to have certain types of vendors that do turnkey solutions. A lot of the mannequin type devices that we see in medical simulation are turnkey solutions. Um, and these are almost always going to be proprietary. And that's going to be a very key feature of them. We learned a lot about vendor lock-in. You are volunteering to be locked in when you buy a turnkey system. It's not going to be typically any sort of open architecture. You're going to buy the entire thing, and any future updates, maintenance, etc., you're going to have to go back to the vendor for all that. Next one is going to be system integrators. So in this case, you may have a bunch of other components, different providers for, let's say, interaction devices, particular models that you're going to need for your application, but you hire a system integrator that's going to be sort of like your prime. And they're going to pull everything together, make sure it all runs for you, but you just need to know that there are lots of other companies underneath them that are actually producing the majority of that content. Here you can actually find open solutions because it may be in the best interest of the system integrator to do something that's open, so that they can maintain their flexibility, which is also good for you. So if you go down the path of a system integrator, you can actually ask for them to conform to open standards, and you can get something that's going to be a lot more flexible than if they go down a proprietary avenue. Next, runtime tools. So this would be like your game engines, things like that. So I'm going to lump these two together, runtime tools and game engines. They're almost always going to be proprietary, although there are certainly open source game engines that are available. I'm not aware of any open source simulation runtime tools. Um, Watch for the licensing costs. If they are per seat, that is per user, or if you have the right to duplicate or run as many copies of your application as you want. That is something to be looking for. So that's typically called what they call it a runtime cost. You're going to want to avoid it if you possibly can, unless you've got a situation where you're only going to need a very small number of something and you know that. You might be able to get your costs down by paying for it by seat. Um, the it depends on how you negotiate this. If you want infinite flexibility to do whatever you want, expect to have a fairly large cost up front, but lots of flexibility on the back end. If you want to gain your if you are willing to give up flexibility on the back end, you can possibly save some costs on the front end. And game engines almost never have any sort of a runtime cost, so you're going to be paying for a license, which will probably be very specific for your application. So you won't have the right. Don't expect that you're buying. You can buy a game engine and do whatever you want. That'll have a cost associated with it. You can also license a game engine for a very specific purpose, but then you don't have the right to go do something else. So expect that. There are certain companies, Epic Unreal being the best example, that have a specific office for dealing with government applications. So you're going to want to deal with those folks. Don't go down the regular avenue like a commercial game would for Epic Unreal. Next is content creation. This is somebody who basically develops content for you. So there's typically models, not whole applications, could be just data, could be just writing code for a particular model that you're going to plug into your application. They can be proprietary, not always, but again, look for the agreement on what it is that you actually own and what do you have the right to modify. The next will be components. This is very common in the gaming industry, where you look at like Havoc, for example, is a plug-in high-end physics engine. SpeedTree would be a plug-in high-end vegetation generator. So you get the very lifelike looking vegetation in some games. That's all procedurally driven. That's not a modeler placing those trees everywhere. That's an algorithm doing it. You can also see things like crowd models. So Mach owns a product called DI Guy. It used to be owned by the robotics company, but now is owned by Mach, where you can get very easily integrate articulated figures, highly precise articulated figures into your model, into your simulation. Just a component. That's all you're getting. The next one, content creation tools. So here you would be like 3D modeling tools like 3D Studio from Autodesk. There's a product called TerraSims and TerraTools for building high fidelity virtual environments. Esri is actually a private company. They sell the very best geographic information system (GIS) tools, which also may be important to you, depending on the type of application that you're doing. But that's just the tool for creating the content, not the content itself. The next thing you might find is support and maintenance. So you'll find this is sort of like the Red Hat model for Linux, if you're familiar with that. Red Hat doesn't make Linux. Linux is an open source product, but Red Hat's model has always been to support Linux. Because one of the things we find in government, we mentioned in the open source module, is that when you want to choose an open source product, one of the pushbacks you'll often get is, who answers the phone when I call? Well, this is a great way to get open source into your organization by hiring somebody who will maintain it for you. So that's what that's all about. There's also model libraries. There are a lot of, you're going to want to look at government-owned model libraries. There are a number of them that are run by different organizations within the Department of Defense in particular. This is 3D content that's already been paid for. We already own it. And if you can get access to the repository, you can save yourself a ton of money and go grab whatever objects you need from it, pull them into your simulation. But there are also other products like TurboSquid and a CG Trader where you can pay for models. And then you save yourself the trouble of having to build it yourself or hire somebody to build it. Just go to a marketplace and buy it. And usually the costs are relatively low, and you'll have the right to use it for a particular purpose. You'll have to pay them again if you want to use it again. Then, of course, there's open source. Again, like what we talk about in open source in general, don't want to really make a choice to be open source or not. In the large, you want to be able to make that choice on a component by component basis. So here you could do something like a scene graph for rendering that is open. We developed something years ago here at NPS called Delta 3D, which was an open source game engine composed of open source components. There's also OpenSim. There's a variety of different open source products out there that are available to you. Just remember they are open source, so you're going to get the code. They typically are not supported. That's why you would need somebody, a maintenance company, to support you. The next one would be hardware, where you're just buying the hardware. So you can think about Barco and Christie sell projectors. InterSense sells some nice tracking devices, cyber gloves, displays, all sorts of different haptic hardware. This is just the hardware itself. It usually comes with software that drives the hardware, but you're going to need to fully integrate it into your application. And then the last thing is sort of an R&D component. We see these guys like Georgia Tech Research Institute, Aptima, some others and universities do this. There's a lot of government labs that do this, that sort of build prototypes, and they do some combination of the things we've been talking about here, but only under an R&D umbrella. They're not really intending to field an actual product. So in summary, here's what we want to say here, is that these models are not really mutually exclusive. You're going to see combinations of them all the time. So you might see tool vendors that also profit from maintenance and support. Very common. So they're going to want to sell you a tool, but they may even give you a break on the tool if you'll sign up for a maintenance agreement, a multi-year maintenance agreement. One of the things that you want to keep in mind is both what things cost now and what things are going to cost you later. Big mistake we make in government all the time is we get suckered into some type of a game somebody plays where they will almost give their stuff away because they know they have a lock-in mechanism built in, and the minute they give you their product, probably at a loss to them, and you start using it, now they got you. So when you come along in year 2 and go, hey, that worked out really well, I'm going to need support for the next year, you find out what you really bought, and you're no longer in control. So watch the both immediate and the downstream revenues and what those costs are actually going to be. Remember that some of these involve lock-in, others do not, to varying degrees. You've learned a lot about lock-in. You really want to pay attention to where it is and how you're going to avoid it, or if you're going to accept it, under what conditions you're going to accept it. Remember, we just want to have our eyes open. We don't want to be surprised. And flexibility is sometimes sacrificed for rapid deployment. So there will be instances where you've just got a hot requirement. You got to get something fielded very quickly. You're probably going to have to go buy something, and you're going to and that's going to have a lock-in involved with it. So you're probably going to have limit your flexibility. Um, so you're going to have a downstream lock-in, but you may be willing to deal with that because you needed to have a solution very quickly. I always feel like this is one of the most important things you can get out of this course is don't be shy about asking your contractors or your vendors how they make money. Um, they're businesses. They need to make money. We need them to make money. If they don't make money, they're not going to be there for us. The government is not built to do everything on our own. We need private industry to do all the things that we need to have done. So we just want to be open and honest about it and understand how they're making money so that they're making money within reason and they're actually being paid with an eye to what their actual contribution actually is to what it is we're doing. So that's just sort of a quick snapshot of mainly the M&S business models, mostly that I've seen in all my years in modeling and simulation. There may be others. I don't claim that this is exhaustive, but I just wanted to give you an idea of how different businesses are going to want to engage you and how they're going to want to do business with you. So your eyes will be open and you can put yourself in the best possible position.